US Physics Olympiad, year 2013, F equal MA. First round. For the first round, that was given 25 problems, and for that it was given 75 minutes. All solutions for all these problems you can find below this video in the reference of the description. Problem number 1. An observer stands on the side of the front of a stationary train. When the train starts moving with a constant acceleration, it takes 5 seconds for the first car to pass the observer. How long will it take for the 10th car to pass? Solution. Here we can use a kinematic equation which connect distance with time, with the initial zero speed. That will be this one. Let's T1 will be the time to pass first car through observer. The length of the first car will be 1/2 a T1 square, where a is acceleration. Same thing we can say for pass of 9 cars and pass for 10 cars. So it will be second and third equation. Now we can divide the third equation by first equation and the second equation by first equation, which give us these two relations. T10 over T1 square equal 10 and T9 over T1 square equal 9. Now we can express T10 and T9 through T1 and subtract for 9 cars to pass observer from 10 cars time 10 cars to pass observer. It will be total time to pass car number 10. And finally we have 0.81 seconds, which is answer E. Problem number 2. Georgie stands 20 meters from a wall and Diego stands 10 meters from the same wall. Georgie throws a ball at an angle of theta equal 30 degrees above the horizontal, and it collides elastically with the wall. How fast does Georgie need to throw the ball so that Diego will catch it? Consider Georgie and Diego to be the same height, and both are on the same perpendicular line from the wall. Solution. In these circumstances, behave like a mirror for elastic collisions. It means that equivalent distance between Georgie and Diego is 30 meters. And here we can use formula for range. Distance equal v square over g multiplied by sine double theta. And from here we can find what is the speed. V square equal d multiplied by g over sine 2 theta, or after putting numbers we have finally speed equal around 90 meters per second. That's the answer C. Problem number 3. Tom throws a football to Wes, who is a distance L away. Tom can control the time of flight t of the ball by choosing any speed up to V maximum and any launch angle between 0 and 90 degrees. Ignore air resistance and assume Tom and Wes are at the same height. Which of the following statements is correct? A. If V maximum less than square root from dl, the ball cannot reach Wes at all. B. Assuming the ball can reach Wes at V maximum increases with the L held fixed, the minimum value of t decreases. C. Assuming the ball can reach Wes at as V maximum increases with the L held fixed, the maximum value of T increases. D. Assuming the ball can reach V as L increases with the V maximum held fixed, the maximum value of T increases. E. Assuming the ball can reach V as L increases with the V maximum held fixed, the maximum value of T increases. Solution. Here we can use kinematic formulas for this problem. First formula connects the change of vertical part of speed for time t, which is this one. And second connects range with the horizontal speed at time t. And now we can use formula sine squared theta plus cosine squared theta equal 1, which will give us this equation. And this equation we can turn to quadratic equation to t squared. Solution for this quadratic equation will give us this expression. First of all, we can emphasize that root with a negative sign are responsible for minimum time, which is for angles less than 45 degrees, and positive for angles theta equal 90 minus theta. That's a positive. And if we look at this square root, we can say that V maximum cannot be less than the square root from D over L. In that case, ball cannot reach V at all. So it means that this sentence is good. Let's go further. For negative sign, we have minimum time, and if we increase L, this root will decrease. It means that the time will increase, which is not answer for D. If we take maximum time and we increase L, this root will decrease and time will decrease, which is for answer E is good, because here we have negative answer, which is correct. So E could be correct answer. Now let's take a look for B and C. For maximum time, if we fix length and increase maximum speed, the time will increase, which is for answer C correct. It means that this is not the answer. For negative sign, we can multiply and divide this t squared by the same function, after which we can get this result, this formula. And now we can see that if we increase the speed v, we decrease minimum time, which is correct for answer B. It means that answer B is not good. So finally we can see that correct answer is D.